All right, I would like to explain to you an electrical diagnosis concept, which is extremely important whenever you're diagnosing anything electrical. You won't necessarily need this technique for every diagnosis, but there will always be a diagnosis that comes your way that requires understanding this technique and understanding how things fail. So the technique is called voltage drop. Taking the voltage drop, measuring the voltage drop, telling someone what the voltage drop is sort of the way that we describe using a multimeter to take an electrical measurement that describes the integrity of an electrical circuit. And this is probably the most important and also the most misunderstood concept electrically among automotive technicians, motorcycle mechanics. If you're working on anything with a battery, this is going to apply. And this works for diagnosing and repairing electrical appliances inside a house with 120 volts AC. Obviously, you have to take greater precautions when working on high voltage, which can shock you. You don't have to worry about that on a car, but nonetheless, the techniques are the same. So I'm going to offer an analogy or several analogies that helped me grasp this concept. All analogies fall short at some point in describing something accurately, so you don't need to leave comments below letting me know that water acts differently than electricity. But for the purpose of explaining voltage drop, it's accurate. It's also how you diagnose hydraulic and pneumatic systems, and so the analogy holds enough water to help you grasp a concept. So first thing I want to explain to you is that this tool, which is used for measuring tire pressure, and this tool, which are used for measuring tire pressure, work the same way as a digital multimeter when you put it on DC or AC volts, okay? Voltage is sometimes referred to as like electrical, the difference, the electrical delta between two voltage sources. And you may not think of this tool as being the same, but it is. So let me explain to you. When you push this port onto a tire, and let's say the tire has 30 pounds of pressure in it, this little thing shoots out to 30. You're measuring the pressure inside the tire, but you're also measuring the pressure in the atmosphere right now, because on this end of the tool is atmospheric pressure. And if atmospheric pressure were 30 psi and the tire had 30 psi, this would actually stay right there. Same thing with this. You're not just taking one measurement, you're actually taking two, and the needle shows you the difference. Right now you're reading atmospheric pressure, which is at 0. When you put this on the tire and you read 30, this thing pops up to 30 because it took pressure in the tire, 30, minus atmospheric pressure, 0, and gave you a value. So these are called relative pressure measurements. What you're measuring is relative to atmospheric pressure. And so even though it looks like this is just a single measurement, it's actually two at the same time. That concept is important to understand in order to understand why I have two leads and where I put them and how they work. So I want to go to a very simple illustration that I have here. This is supposed to be a garden hose spraying water out at the end. And what I want you to imagine is that if I took a pressure gauge and I took a pressure value and I cut a little hole in the pipe and I took a pressure value like this, and I had my gauge, and then the other part of my gauge is just connected to the atmosphere, I would read, let's say, 30 psi, okay? But if I took a different pressure gauge, let's use a different color. If I took a different pressure gauge and I connected one part of the pressure gauge to the hose and another part to the hose, what would it read? Well, if the hose had 30 psi in it, then this side would read 30 psi, and this side would read 30 psi, and so the gauge would actually read 0. This would be what we call a differential pressure sensor. You have them on exhaust systems for diesels and things like that. Now, again, I know that to you, this gauge might look like it only has one port, and I've drawn it with two, but again, you're actually taking two measurements. So if you had a gauge that looked differently, that had two hoses, like a digital multimeter that has two leads, then you would have this exact situation. So if you compare to atmospheric pressure, you get 30 because there's 30 in here, 0 out there. But if you compare one part of the pipe to another part of the pipe, you actually get 0. And so when you're taking voltage drop measurements, the best result you can get is 0.00. because what that means is there's no difference from this part of the garden hose to this part of the garden hose, or this part of the wire to that part of the wire. Now, let's imagine for a moment that there's something wrong with our garden hose and a little kid has run his bike over the garden hose and kinked it. Okay, so let's imagine that that's a kink. Now, if the water's coming from this direction and it's at 30 psi, then as it tries to run through this little restriction, it's kind of like all the lanes on the highway going from 5 lanes to 1 lane, it starts slowing down. And so the pressure will remain here at 30, but let's just say, for sake of conversation, over here it's at 5 psi. Okay? Now, if I hook up my gauge and I go from this side of the restriction to that side of the restriction, I'm not going to read 0 psi anymore. I'm actually going to read 25. And so you could say there's a 25 psi pressure drop. The pressure from one side to the other side drops due to the restriction. That's exactly how it works electrically. If you have a wire, now imagine the garden hose is a wire, and you have, let's say you have 12 or 13 strands inside that wire, and all but one of them are broken. That is the electrical equivalent of a kinked garden hose. Or if you have a bunch of corrosion and it's nasty and green and doesn't conduct electricity very well anymore, that's the same thing as a restriction. And so if you take a multimeter and you go from this area to this area and it reads 5 volts, what that means is that there's a restriction in the system, an electrical restriction or resistance, which is losing you 5 volts. So that's the theory. Hopefully the analogy helps you. So now let's draw a quick circuit and I'll show you why this is necessary. So let's say you have a battery. That's the positive terminal. That's the negative terminal. Comes out, goes down, and we're just going to do this. That's your load. And then, I should have used a different color, sorry folks. Let's say this is your load. Okay, this is a light bulb. And this is resistance that you don't want in the system. Okay, and then on the other side of the light bulb, you have your ground circuit. Okay? If you basically take 2 voltage drop measurements, in a perfect system, you take 2 voltage drop measurements. You go from the negative battery post to the ground side of the load as close as you can, hopefully back probing the connector. And you should read something that's close to 0. Then you would go positive to positive, and you would also hopefully read something very close to 0. Now, the prerequisite for taking a voltage drop measurement is that the electricity has to be flowing. Just like the garden hose has to be on and flowing, it has to be flowing. If it's not flowing, then it's like the garden hose analogy, except you've plugged the end with your thumb. And if you plug the end with your thumb long enough, the 30 psi that's over here will sneak through the restriction and make 30 psi here too. And that's not what we want. That's why you may have sometimes turned on a garden hose and it trickles out the end, but then when you crank it up full blast, it doesn't come out. It's because there's a restriction somewhere. It's the same general idea. Now, if this were a situation in real life, I would go from here to here and it would read close to 0. When I went from here to here, it would read, let's say, 3 volts. And what that means is that I'm losing 3 volts right here in this corroded or broken connection or terminal or something like that. Now, a lot of times you have a bunch of things in play. You might have a fuse, you might have a relay, you might have electrical connections, you might have all sorts of things. And so you actually have to isolate the system by going like this. Let's say you get 5, then you'd go here, then you get maybe less than that, less than that, less than that, less than that, and you can isolate whether the problem is between the battery and the fuse, or the fuse and the relay, or the relay and the connector, or the connector and the load, and so you can isolate the circuit. Now, on a car, we have a nominal voltage of 12.6 volts. And I have heard many numbers over the years, over the last 20 years, of how much voltage drop is acceptable. Now, the acceptable voltage drop, technically speaking, is based upon how many amps are flowing through the wire, how big the wire is, and what the voltage is. But I can tell you from practical experience, 20 years of working on cars, anything more than 0.2 might give you a trouble. I had a Volkswagen once, it had a check engine light on. The fault code was for a power supply failure. We voltage dropped the circuit from the plus side to the engine control module, and we got like 0.39, something like that. So not much higher than 0.2, but a little bit higher than 0.2. And we basically found a slightly corroded terminal end, which may have been getting higher resistance once it got warm, but we cleaned that up and we went down to like 0.16, I think it was, 0.16, something like that, and the check engine light never came back. Now, that's on a very, very, very sensitive diagnosis circuit like an engine control module, which is very complicated. A 0.2 voltage drop is not going to be the reason that your blower motor spins slowly, or the reason that the starter motor doesn't turn on at all, or anything like that. So you have to take this number with a grain of salt. If you're trying to diagnose a very slowly turning radiator fan, you're going to be looking for something more like, 2-volt voltage drop, which is going to cause something like that. 0.2 isn't going to cause it. But if it's a diagnosis circuit or a 5-volt circuit or something very sensitive like a camshaft position sensor, then 0.2 can already be enough to cause some trouble. Okay, last thing I want to make note of is some of you may be familiar with a continuity test. So you may be wondering, can I just do a continuity test? And if not, then why not? And I'll explain to you the reason. When you do a continuity test, the 9-volt battery in your multimeter is actually sending a very small amount of electricity up one lead and down the other. And basically it knows how much it sent out and it's checking to see how much comes back, okay? And so it's essentially doing its own voltage drop test. The problem is that it's sending a minuscule amount of amperage. And if we use our garden hose analogy, it would be like just trickling out the end. And so a hose, which has a major kink in it, can still flow some water. Now, if the hose is cut in half or completely kinked, it won't. And so a continuity test can help you find really big, serious issues where wires are completely broken and missing. But if you have a blockage of even 90%, it'll still pass a continuity test. And when I used to go to training at Volkswagen, they had a really cool illustration. They had basically a real thick, this pinky sized thick battery cable, and the instructor had cut away all the filaments inside the cable except for one. And it passed a continuity test all day long, but it would always fail a voltage drop test. And so when you do a voltage drop test, you have to imagine that you're turning the garden hose on full blast and you're checking to see if it can put out the 5 gallons a minute or 10 gallons a minute or whatever that garden hoses do, but you're doing that electrically. So you want the circuit loaded and on with as much amperage as possible. That means if it's a blower motor, turn the blower motor up to speed 5 or 6, whatever the max is, and then take your measurement. So I hope that was helpful to someone. Voltage drop can be a real mystery, and without a proper understanding of it, there are some problems that you will never find in a car or lawnmower or whatever. It's also extremely aggravating when you don't have an understanding of something like this and you hear people talking about it, and it can also be intimidating. So what I would encourage you to do is think about how this is taking 2 measurements, inside the tire, outside in the atmosphere, and it's subtracting them from each other. If they're the same, it reads 0. If there's a delta or a difference, it reads a number. The multimeter is doing the same thing. When you go from plus to plus or minus to minus, it's showing you how much you've lost in between. It's showing you the delta, and that delta is what we call the voltage drop. I hope that was helpful to you. If not, give it a thumbs down. Go have fun on YouTube. There's a lot of good stuff on there. Maybe something else will help you. Take care, guys.